All right, so welcome to our second meetup. Reminder again, if you're not speaking, go ahead and mute yourself. I think everybody's been doing a pretty good job of that so far. Today, I guess three things on the agenda. First, we'll take a look at some R code to help you get ready for your next project, and then second, we'll take a look at just a couple of examples of the split, apply, combine methodology. And then that'll leave us some time at the end for questions and concerns. So I thought we would just spend today mostly working just right in RStudio rather than having any kind of a lecture. So as a first example, your upcoming project here, project number 2, is going to ask you to analyze a data set and give us some insights into that data set, and you have an assignment. Let me actually pull that up here quickly. Let's see. Here it is. And as part of this assignment for week 4, what we'd like you to do is take a look at this data set and include a visualization in support of your conclusion. And so we'll take a look at that. The instructions do say use the ggplot2 package. However, because it's your first go at graphics, I'll leave that up to you. If you want to use the base graphics, that's okay too. But you do need to start familiarizing yourself with the ggplot2 package. So this is due next Tuesday. September 23rd, I guess. Sorry about that. So next Tuesday, have a go at this and let me know if you have any questions. I've been on the road all day yesterday and today, so if there have been any questions posted in the discussion forum in that time, I haven't gotten to them yet. So have a look at those. You've also got your quiz that's due for tomorrow using the same data set, right? Are there any questions before we begin? Is there any difference? So there should be a difference between the two assignments. So the assignment has very specific questions. So here's the quiz. You want to provide R code that answers these questions here. Very specific questions. How many movies each decade, average rating, and so on. And then in the assignment, let me pull that up here. You're actually asked to answer this question here: which were the best popular movies made? And so that's a little bit more general, a little more open-ended, but you're going to use the same kinds of tricks and tools to answer the question and provide supporting evidence. Okay. Any other questions before we start? As a reminder, this is being recorded, so don't say anything you don't want evidence out there existing.
For the quiz and assignment, do you have any recommendations of what sort of, just examples of what sort of evidence you would like correlations, regressions, stuff like that?
No, I think I want to keep it open-ended. The stuff in the quiz gives you a clue for the sorts of things you can use, but yeah, no, I'm more interested in seeing what you guys can come up with than giving you just do this and turn it in. I want to let you guys have a little bit of a shot at doing it on your own. So I think I don't want to answer that right now. Sorry.
All right, thanks. No problem.
I'll be happy to discuss that in much more detail after next Tuesday. I'll put it that way.
Mm-hmm. Mm-hmm.
But the quiz questions give you some hints to the sorts of things you can do. Most of the time, the best kind of evidence can be presented graphically. So, or I won't say most of the time, but a lot of the time. So if you can create some visualizations that support your claims, that's always going to be a good way to try and argue for what you're claiming.
Mm-hmm.
Any other questions? Okay, so let's jump in into our studio here and just take a look at some key ideas. So the kind of thing you might do, I'm going to take a data set that we're using in my probability class, and we'll load this data set in, and I'll send out the code and I'll attach the data sets as well that we use tonight. But I'm just going to go ahead and read this data set into my RStudio environment. And so this is a data set on jurors, and it comes from an analysis that was done for an appeal of a trial back in the 1970s, and a guy who was convicted of armed robbery, I believe, burglary or armed robbery, one of the two, down in Texas, and he was in a county that was 79% residents of Mexican ancestry. And he was arguing that he did not have a jury of his peers because there were not enough jurors of Mexican ancestry on the jury. And so in his case, there were 7 out of 12 that were of Mexican ancestry, and that's lower than 79%, of course. And so the question was whether it was too unreasonable or whether 7 out of 12 was reasonable given a 79% overall population. Now, we're not going to be able to answer that very definitively in this course, but at least what we can do is use this as an example of how to pull a data set apart and take a couple of looks at it. So this is, I know it's kind of small on my screen. I'll zoom it in here just a bit. But the idea here is that each jury has 12 people, and so each row is one jury. And the only information we have in this data set is whether they were of Mexican ancestry or non-Mexican ancestry. And of course, non-Mexican includes a lot of things, but for the purposes of this analysis, we were only interested in Mexican versus not. And so that's all we've got here. So there are 13 columns. The first column gives a unique ID number, and the second column through the 13th column just give the ancestry of the individual jurors. And so this is a data set you might get that you're asked to do a basic analysis. And we'll just make a note here from RStudio. There are 70 juries in the sample. So from a statistical standpoint, that gives us a reasonable sample size. Again, this isn't the stats class, so we won't get into that too much. But what are the kinds of things that we might want to look at here? So I have a few things in mind, but why don't you guys tell me, either in the chat window or go ahead and speak up.
So what's the question we're trying to answer again? Whether
that's what I'm asking.
The jury he ended up with. Oh, I see.
Yeah. So before we get into trying to answer a specific question, just what kinds of things would you want to look at? Yeah. The overarching question here is whether there were not enough Mexican jurors, Mexican ancestry jurors, right? They're Americans, on his jury. But what kinds of things would we want to look at? So Jordan says we might want to look at the proportion of non-Mexican jurors. So a histogram of the percent of Mexican, right? Distribution of the proportions. Okay, so the data frame is not in the most friendly format for these kinds of questions. So one of the things I'll do here is I'll go ahead and I'm going to show you how to use a library called the Reshape2 library. There's a Reshape library, and then there's a Reshape2 library, which is an update of the Reshape library. So you still see mention of Reshape every once in a while, but I would recommend using Reshape2. And of course, if you don't already have it installed, you'll need to install the package. But this will give us a function called melt. And what we're going to do is we're going to take this this data frame, and we're going to create one column for jury ID, and then the next column will say which juror, so juror 1, juror 2, and so on, and then the third column will give the actual value. So this will let us have it basically be a vector of just Mexican, non-Mexican, which will be much easier to analyze. So let's see, Paul, you're asking why we need the data frame. Yeah, we could. We could run a Monte Carlo simulation. There are a lot of different ways to tackle, but you know, don't upset me because what we're learning here is how to work with the data frames and not the statistical analysis. So, but okay. So what we're going to do is we're going to look at a way to reshape this data. So this is commonly called unpivoting the data. So if you use Excel a lot, you probably use pivot tables. We're going to do what's called unpivoting the data or melting the data. And so there's a function called melt in the reshape2 package. So here's what we would want to type. So we're going to say create a new data frame. I'll call it jury data 2, and it'll be melt jury data, and you have to tell it the ID column. And this doesn't matter so much for what we have because there are no missing values, but you have to decide whether you want the missing values included in your new data frame. And so I'm going to say no, I don't want to include them, but there aren't any in this data frame. So I just throw that in there so you're aware that it exists. So when I run that, I now get a new data frame, jury data 2. And when I take a look at that, now it's in just a column form. So juror 1, and then if we scroll down further, juror 2, and so on. It's not quite as nice as we might like it. Two things we might want to change here. First is that the column names are kind of lousy. Variable and value don't have a whole lot of meaning for this particular problem. So what I'll do is rename the columns. And then the other thing that's not particularly nice looking here is that I've got all of the juror 1s listed, and I think I would personally rather have them listed by each jury, 12 at a time. Right? I don't know about you, but that's my preference. So what I'll do is I'll use the order function, right? And I'll order them by jury ID first, and then by juror. So it'll say, for this jury ID, jurors 1 through 12, and then for the next jury ID, jurors 1 through 12, and so on. And in a client environment, I probably would not call these 3 different data frames. I would probably just call them all the same thing so that I'm not filling up memory. But when you're developing your code, this isn't a bad idea because it lets you go through and see how things change. And yes, Charlie, I'll post the code. So if we now go take a look at jury data 3, we can see now it's got the first jury ID and jurors 1 through 12. If you're curious, this nuisance of row names here on the left, there is an easy way to get rid of it, and the easy way to get rid of it is just to set row names for the data frame to null, like this. And once I run that code, if I go take a look at it, that column no longer displays. That doesn't mean it gets rid of them. It's still there. Every data frame has row names and column names, but this way they're set back to 1 through 840, and since that's what appears in this left column, it doesn't display them again separately. So this is now completely reordered. It would be impossible to go back to the original data frame exactly. We could get close, but we might not have the jury IDs in the same order. So by saying row names is null, I've gotten rid of that bit of evidence that we would need to go back. Okay, so let's take a look. What we really want to know is, for instance, what each jury looks like, right? How many juries have 7 of Mexican ancestry? How many have 8? How many have 6? And so on. And there are several different ways we could do that. There are some different approaches, but in particular, we want to kind of show you a couple of different methodologies here. And so I'm going to use a flag column. And so all this does is, besides giving me a chance to show off the if-else function, it's going to create a column that says if the person's ancestry is Mexican, say 1, otherwise say 0. So if-else, if the ancestry column is Mexican, we put a 1, otherwise we put a 0. And so when I run that, now I have a 4th column of 1s and 0s. And the reason that that'll be nice is because now I can start to look at the composition of each jury. and I can start to add those numbers up. So here's the aggregate function, and if you haven't seen the aggregate function before, this is part of what we call the split, apply, combine methodology. And so the aggregate function is going to say, I want to know the value of some function for each of a certain ID. And in this case, what we're going to use as our ID column is the jury ID column. And so what I'm going to want to know is, for the flag column for each jury ID, what's the mean? And that's equivalent to saying what percentage were of Mexican ancestry. Right? Because if I have 7 ones out of 12 jurors, that's going to be, the mean is going to be 7 divided by 12. And so a column flag, with ones is often useful for these kinds of calculations. So what I'll do is I'll run this, and then we'll go take a look at the outcome, jury composition 1. And we see for each jury, we now get the percentage of Mexican ancestry. And so, Jordan, to your question, why is it by equals list? The aggregate function requests a list, and so you can aggregate by more than one variable. So you give it a list of the variables that you want. So we could have aggregated by, well, I guess in this case, jury ID and juror, but that wouldn't be very interesting because we're only aggregating for each row then. But you can give it a list of several variables to aggregate by. You may have noticed as well, if we looked at that data frame, when you use the aggregate function, it'll give group.1, group.2, group.3, and so on for all of the aggregating variables, and then X is the actual result that you get. So that's, again, not a very friendly set of names. In this case, I calculated the mean, and just a couple of things to note here. There are several functions you can use. You can use mean, you can use sum, you can use median. Most of the functions that are part of base R that work on a numeric vector will work here. So for count, I don't believe you can use count directly, but since we have just ones and zeros, you could do a column of all ones and then do a count on that column and by doing a sum. So I don't believe count is possible, but create an extra column of ones and then do a sum, and you'll get that. So the other thing to notice here, the most common typo for the aggregate function, FUN for function has to be capitalized. So don't use lowercase. So I'm going to change the names so that they're a little bit easier to read, and I'm also going to do, I didn't do this earlier, but I'm going to take the percent column and I'm going to round it. Three decimal places. So now if we go take a look, we've got it in a little bit nicer format to take a look at. And we've got all 70 juries. And now we could ask questions like, what's typical? So we could do, we could do a visualization here. We'll get to those in just a minute. We might not want to know the percentage. It might be easier to do a count rather than a percentage, because we know that all of these juries have 12 people. What I'll do here is run the aggregate function, and here function equals sum rather than mean. We'll count how many. It'll count how many of Mexican ancestry because those were the ones in the data set. So there we go, jury composition 2, and again we've got group.1 and X, but now X is a count. And so again I'll rename my columns so that I've got a count. And then the last thing I'll do here, just in terms of manipulating the data, is I'll merge these two data sets together so that I've got both percent and count in the same data set. And once I do that, come over here, and now we can see both percent and count. And just a very quick eyeball down this shows me that I'm not getting very many that are more than about 6. There's a 7 there, another 7, oh, there's an 8, but in particular I'm not noticing any 9s, 10s, 11s, or 12s. So that, when we get to the statistical analysis, that could be a little troubling if we think if we know that 79% of the population are of Mexican ancestry, and on 70 juries, the most we have is 8 of Mexican ancestry. That's only 67%, right? 2/3. So that should be a little troubling already. So let's go back to our code here. And now we might be curious, what are some of the different counts and how often do they occur? So the table function is one of the most used functions in, well, for me at least, in R. And so here's a table of the different number of jurors of Mexican ancestry here. And we can see that the most seem to cluster in 4, 5, and 6. And we never get higher than 8. So I don't know about you, but if you presented this table to your boss, you'd probably be told to go away. So what we really would like to do is create a visualization. And I'm going to do just base visualizations tonight. Again, you can use either base or ggplot2 for the assignment. So here is just a simple bar plot of that table. And if you do a bar plot, you have to tell it a numeric vector that gives it the heights. But you can use a table, and by doing a table, what you'll see here is that not only does it use the heights from the table, 1, 1, 5, 11, and so on, but it'll assign the x values, the labels, from the table as well. So you don't actually have to assign them yourself if you get this from a table. So that's a useful thing. We can make this visualization better in a lot of different ways, and again, I'm going to show you some of the possibilities, but your job over the next few days is to investigate others of these possibilities. It's always good to give the table a title, or the visualization a title. So I'll just say jury composition analysis for 70 juries. And so now I have a title. What else might we want on here? Anybody?
Labels on the X and Y.
Labels on the X and Y. Okay. So I'm going to do the X label first. So we'll say X is a count of the jurors of Mexican ancestry, right? Oops, got to run both lines. So there's a label on the X-axis here for what these counts represent, how many jurors of Mexican ancestry. And then, of course, the Y-axis is counting those, right?
Right.
And so I'll say number of juries on the Y-axis. I've also done something here, I don't think I mentioned it. I've made my Y labels go all the way up to 20. I set the limits. Let me move this over for just a second. I set my Y limits from 0 to 20 to make a little bit friendlier scale. I'm going to go back to the original graphic for just a second here. See, I don't like it when the bars go higher than the top label of the axis. So that's me personally. That's the same part of me that says never ever do a pie chart. So I lengthened that axis just a little bit to make it a little bit friendlier to read. So that's a decent graphic. Right? That conveys the idea here. We could do more with it, but I think if somebody were asking you summarize what the number of Mexican jurors on these different juries look like, this would do it, right? What's one piece of information that's missing from this graphic? In other words, if somebody just looked at this, what's it not conveying?
The average?
Okay, but we can get a sense of the average, right? It looks like sort of the middle is around 4 or 5, maybe somewhere in there. How it compares to the population? Okay. But even more basic than that. What might we be taking for granted? There we go. So Paul's got it. The number of people in a jury. This ranges from 0 to 8, but it doesn't say that the juries each have 12 people. All right, so that might be something you'd want to think about adding in. So you could either do that by virtue of putting it in the title or extending the x-axis There are various ways to do that. Okay, so I'm going to let you guys fiddle with that kind of stuff, and I'm going to move on. So the first thing I'll do before I move on to the next example, and again, you can have this code when I'm done and play with it. Actually, I'll post a version of it that's got more comments separating things out so that you can read it a little easier. So I'm just going to clean out my environment because I don't want to have too cluttered an environment. And I'll clear out all the plots. Not essential, but it's generally a good idea. So let me basically start a little bit of a fresh section here. All right, so for the second example, we're going to use some baseball data, and we're going to take a look at the sapply function. So the data that I'm using, the website it will be given right here in the code. Yes, the clear button is the same as that remove command. So the baseball data comes from this website, so I'll include that in the script, and you can go get it yourself. But I'll also attach the CSV files that we're using. So I downloaded them and extracted them to a directory. They come in a zip file. And so the first thing I'm going to do is read in the batting data. And this is data by season for various players for Major League Baseball for a lot of years. So there are 97,889 observations. Of course, we know this is a tiny data set in the real scheme of things, but it's not one that we could easily just go through on our own and visualize. And so it's got a player ID, and then it's got a year ID, and then it's got a number of different variables here for each of the players. I know what most of these mean. League ID is American League, National League, games where they were batting, at-bats, runs, and so on. So if you're a baseball fan, this stuff probably all makes a lot of sense. If not, just bear with me, and we'll use some examples that I think everybody could follow. So we might want to just explore this data set just a little bit. So, and I do want to talk about one thing in particular. But the first thing I usually do when I pull a data set in is I go and I view it. The second thing I do is run the structure command, and then I take a look at what that tells me. And so in this case, we don't have too many variables, so I can view this all on one screen. But it's a data frame. It's got 97,000 some observations of 24 variables. And the key one here for me is that the player ID column is a character column. And the way I made sure that happened is I used, we've talked about this I think before, this strings as factors equals false command in the read CSV function. So that's a common, I don't want to say it's a mistake because you might actually prefer them to come in as factors, but it'll be not uncommon for people to start reading in a data set and trying to work with a character column, and they don't understand why they can't run all of the normal functions that are run against a character column. And it's because they forgot to do this, and R is recognizing it as a factor instead of a character column. So this strings as factors equals false is extremely useful, and it works in the read CSV. It also works in the data frame function command. So if you create a new data frame using the data frame function, you can also use strings as factors equals false. In fact, that was in, I forget which of the quizzes it was in, but there was a question that asked you to create a new data frame using the vectors that you had created and then run some functions against them. This would make your life very easy. If you didn't do this, one of the problems that was about a 2-line solution would become about a 12-line solution. So strings as factors equals false. I've used it about probably 25 or 30 times already this week at work. After I run a structure, and just quickly we'll notice that the team IDs and league IDs are character as well, and everything else is coming in as an integer. And so this would be the point where we would manipulate all of that if necessary. I also like to run the summary command, and this is a little bit harder to fit in one screen, but so what we get here is just a summary of each variable. For the character variables, we get the length of the vector, the class of the vector, and the mode. But for the numerics, we get a summary, right? We get the 5-number summary plus the mean. So we get the min, first quartile, median, third quartile, and max. So this can be useful, if you wanted to find out, well, what's the first year in the data set? Now I can tell you it's 1871. And so we get that for all of the different variables. So let's see, we've probably got, let's see, where's, let's see, RBI. Home runs, I'm looking for, here it is, okay. So home runs is right here, so we can see 73 is the max number of home runs. So we know now the current record, at least through 2013 for home runs, was 73. We'll stay away from judgments on the merits of that number. Okay, so some questions we might ask. So I'll ask a relatively simple one. Who led Major League Baseball in hits in the 1950s? Anybody want to take a guess? Type it in the window if you know. No Googling. So that's not an easy question to answer from this, right? Because if I go to the data, again, I'll just take a quick peek at the data frame. It's for each player for each year. So what do I do? Well, we're going to have to, somehow for each player, we're going to have to add up the number of hits they had, right? That's what we want to do. So you guys have learned how to use functions, so I'm going to write a function that does that for a single player. So here's my function. I'll call it sum.hits in the 1950s, the full decade, 50 to 59. If it was just 1950, yeah, that'd be a much easier question. So this is a function that it takes a player ID, and I'll call that player in my function, and then it takes the what I'm going to do is take the 1950s batting data frame, which I haven't yet created. I just realized. So I've got them out of order in my code. But it's going to take, we're going to subset the data just to the 1950s, and then it's going to create that data frame, and then it's going to take a sum of the hits for this player, whichever player we specify. So let me back up a second. Sorry, I threw myself off here. I'm going to create batting 1950s from the batting data frame where the year ID is in 1950 to 1959. Okay, so now I've got just 6,148 observations. 30 years ago I would have just taken a grad student like one of you and said add these up by hand. But nowadays we can do this much faster. Okay, so the first thing I need to do is create a list of all the unique players. So I'm going to use the not duplicated function here to create a list of all of the players in the 1950s. And we'll notice over here it's a character vector, and there are 1,562 players. Just so it's on here, there's an alternative function that would do the same thing, which is the unique function. I don't know why, I just use not duplicated most of the time. So I'll put it here as reference. It'll be in the script you guys get, but you could use the unique function as well. Seriously, you had to Google it? All right. So I have my list of players, and what I'm going to do now is apply our function to each player. Good question. Jay's asking, what's the purpose of an open comma? So the way R reads data frames is inside these brackets. Before the comma, I tell it what rows. So I'm saying I want the rows where player ID equals the player in question. After the comma, I tell it which columns I want. In this case, I want all of the columns. So if I leave it as blank, it'll by default just take all of the columns. But I could, for instance, say I want columns 1 through 3, or I could give it a list of the numbers of columns. Right? There are any number of ways I could do this after that comma to tell it which columns I want. But in this case, I just want all of them. So I'm going to do comma and then just leave it blank. Let's see, Daniel, you're asking, does levels as factor? Yeah, I believe so. That would work, but again, there's really no reason to make it a factor, and actually, yeah, I'll just leave it at that. Yeah, that would probably work, but I wouldn't do it that way. Okay, so we've got our data frame for the 1950s, we've got our function written, we've got our list of players. All that remains now is to apply the function to each player. So we'll use the sapply function, and what that's going to do is it's going to say, take a list, in this case, or a vector rather, of each of the individuals you want to run the function against, and run this function against it. And the output of this will be a vector. I got to run the code. So put the function in memory, and now I will apply it to all of those players, and what comes out of this will be a vector as well. And you'll see here hits 1950s is a vector. It's 1,562 long, so that's good. It matches the number of people in the player list. And if I view it, and I'll just type it in here. All right, there's our vector. And you can see it's assigning to each value the player ID as well. And sorry, that's a little bit hard to read that way. Not in the friendliest of formats, but does the job. So if we want to put it in a little bit friendlier format, here's one way to do it. I'll create a new data frame. Batting analysis hits 1950s. I have discovered a feature of RStudio that a week ago, had you asked me whether this was a reasonable name for a variable, I would say, no way, it's way too long. I don't want to type that over and over. But in RStudio, once I run this and create this new data frame that just says the first column is the player list, the second column is the number of hits each player got, if I need to type it again, I just start typing it, so B-A-T-T, and hit the tab button, and now I have a choice of all the things that start with that. And I can put it in. So there's a, so there's a shortcut for getting all of those things. So I was asked a while back whether RStudio had an autocomplete feature, so I decided to look it up, and sure enough it does. So that's a wonderful thing, and now I don't mind long names for variables. All right, so there was a question here. Is there a way to update the data frame in place with a custom function and an apply function? I'm not aware of a way to do that. So I can look into that, but I don't know of a way to do that easily. Okay, so I'm going to take a quick look at this data frame here, and we've got the row names and the player list both in there, and so that might be annoying. We don't need to have them in there twice. We could run a check for quality control to make sure that they match, but they do. I'll just tell you now they do. And so what I might want to do is we could get rid of that column of row names if we didn't want it. So the first thing I'm going to do is order this so that we've got them in order by number of hits. And so let me scroll over so you can see the whole thing. So I'm going to take the data frame and I'm just going to say replace it with itself but ordered by hits. And again, here's that column, that comma at the end so that we select all columns. Now, before I look at it, what's the problem with what I just did? It's purely a practical matter. The code runs just fine. But what's the problem with what I just did? Anybody want to guess? We're ordering this. This is a common problem when you sort things. Well, I don't know, Tulasi, it's okay. It works just fine.
Is it that you're overrunning the first data set?
Well, so Adam's got the answer in the chat window, right? It's not going to be in descending order. So when I go take a look at it, it starts with all the zeros, and that's not what I really want to see. So for the order function, a useful thing is to just say decreasing equals true. And now when I run it, we get the player at the top with the most hits. I do not know who that is. However, there is a, and before I do this, let me just, I'm going to get rid of that row names column, reorder it. There is a master table, however, that has actual player names. So what I'm going to do is I'm going to read that table in. And again, I want to make sure I do strings as factors equals false. And these tables all have headers, so I did headers equals true. And this is just a master table of player information. So there's their ID, what year were they born, month, day, country, and so on. If they're dead, what year they died, and so on. If we go way over here, though, we get their names. All right, so that's what we really probably want, is to know these people's names. One thing just to pay attention to, Hank Aaron, his given name was not Hank Aaron, it was Henry Lewis. So when you merge these data sets, be careful there. If you use the given name, you might not recognize the player. So what I'm going to do is I've got that in there. I'm only interested in the names for this analysis, so I'm going to take the master data set and I'm just going to subset it. Here's another way, by the way, to identify the columns that you want. You'll notice I'm taking the master data frame, all rows, because there's nothing before the comma, and then I'm going to say only take the columns where their column name is in this list. So I give it the 3 column names I'm interested in. So this will take the master data frame and it'll just say these 3 columns. So that's a useful trick if you don't want to sit in there and count how many columns over each one is. If you have a data set that has 300 columns, well, was it 285 or 286? I don't know. And what if your code changes? Then you got to go back and recount. So if you just say, I want these 3 column names, this is a way to do that. So when I run that, now we'll see that this data frame just has player ID and then their first name and their last name. And I went with that rather than given name because I want to know, Hank Aaron, for instance. That's what I want in there. Okay. So what I'm going to do is I'm going to merge these now. So my final output, I'll call it final hit analysis. So I'm going to merge the batting analysis hits 1950s data frame with my merge master data frame. The column in the X data frame, which is the batting analysis one, that I'll merge on is player list. In the Y data frame, it's player ID. If they have the same name, you can just say by equals player ID. But because the columns have different names here, I'm just going to specify what they are. And so when I go ahead and merge these, let's notice we get final hit analysis over here, 1,562 observations of 4 variables. And when I click in it, here we are. Again, we get first name and last name plus number of hits now for each of the players. And but we could clean this up again. Notice that now that I've merged it, they're no longer ordered. So that's a little bit annoying. So we go back and we say, okay, well, let's just reorder them. So it's the same code as before, but for this data frame. So I'm going to order by the number of hits that each got. And now if I say, okay, who had the most hits? We come in here and we say a guy named Richie Ashburn had 1,875. I know that appeared somewhere up in the chat window. Whoever you are, I'm taking 10 points off your next assignment. Except I'm not going to take the time to find out who you were. Oh, Tulasi ratted you out, Adam. Okay, so that's a simple split, apply, combine methodology. Split the data set by player, apply a function, in this case we added them up, and then combine it back into a data set. So the sapply function is useful for applying numeric functions to a data set. Are there any questions at this point? Okay. So we have about 10 minutes left, maybe 8 minutes left. I will at this point open it up to questions. I'll post this code and also some the data sets that go with it, probably by about 9 o'clock because I have a second session I have to run at 7:45. So I'll post them after my second session. So Paul, you have a question? Go ahead.
So in the book, Or for Everyone, the author talked about how sometimes iData frame would have a speed advantage over regular data frames, and then he proceeded to give kind of like a profiling, both a regular data frame and an iData frame, which is great, except that the numbers were actually higher for the iData frame. So if those numbers were seconds or milliseconds or whatever, I guess it was kind of lost on me how that demonstrated the superiority of iData frames. So when are they better? And are they better?
I'm going to answer your second question first and say no, not really. That makes the second question much easier to answer. I have no idea why you'd use them. So there are ways to use them. I don't use them myself, so I don't want to speak to the advantages. I can look into that and try and get back to you.
Yeah, I mean, I'll have a look, see if I can find the specific. Well, I have the Kindle edition, so I can't exactly give you a page number, but
no, I know what you're talking about in the book, and I know exactly what you're saying, but I don't use them, so I don't.
Okay.
I can't speak to their advantages. I don't. I'll have to look it up, to be honest. So.
Okay. Fair enough. Thank you.
If you if you ask that in the discussion threads for Ask Your Instructor, I'll put the answer there.
Okay, sounds good.
All right. What else? Anyone else? Let's see. Okay, so yeah, Jay, if you want to go ahead and start a discussion thread, that'd be great. Any other questions at this point?
Just a quick one. For the week 4 quiz, is it supposed to be an R document or an R markdown?
So Brett, I think if I heard you right, you asked for the quiz whether it's supposed to be R or R markdown. I believe for the next one you have your choice. Let me look. So, that's the assignment. For the assignment, it can be either. And I'm looking for the quiz here. Hang on. For the quiz, in a single R. Okay, so either one. I'll just say either one. A quick example of R Markdown. Sure. So for R Markdown is used to create HTML pages. It's a Markdown language. I will say, however, if you use R Markdown before I do this, don't submit the published HTML. Submit the R Markdown file itself. If you submit the HTML to GitHub, it doesn't render as a web page. So that makes me have to navigate through your HTML code, and that makes me cranky, and you guys don't want me cranky when I'm grading. So what we'll do is new file R Markdown. Let's see. And apparently my version of RStudio is still a little out of date. So we'll go ahead and update it quickly. And then you can choose your default output. And I have LaTeX on this machine. I believe I have MikTeX. Whoa there. So RStudio is developing new stuff all the time. So this is great. So this will be just a test document. And it just creates the document for you right here. and you put R code inside. You can see with the symbols here to put R code within, and what it'll do is show the code, and then it'll also show the output. You can embed text, you can do links, you can do all sorts of stuff, and so there's a lot of stuff out there in Google. You can write in LaTeX. Yep, you can write in LaTeX in here as well. But you'll see at the top here a number of things that you can do, and then when you're done, click knit HTML. It'll process it. We'll hope that my having a slightly out-of-date version of RStudio doesn't make this fail. Yeah, so I think because I've got an older version of RStudio on this machine, it's not going to want to run for me. So I'll tell you what, we'll show R Markdown in more detail next time. Again, for these assignments, you've got your choice. If you don't want to try R Markdown, or if you want to try it and then it doesn't work well, just use an R script. So because we only have 2 more minutes, I'll put together, and I'll tell you what, instead of waiting 2 weeks, I'll put together a short video on R Markdown when I'm not doing it on the fly, so I can make sure everything's up to date and then works correctly. So I'll try and post about a 5-minute video in our content. So a good rule of thumb, you're all going to be presenting someday. Don't present stuff you haven't prepared ahead of time. So you'll notice I was copying and pasting all of my code from another screen rather than writing it as I went. Any other questions? Procedural questions? R questions? Yep, so there's a lot of help on the web. I hope to be caught up in grading by Saturday, for those who might be curious. The entropy projects, a lot of them look pretty good. Those that don't look pretty good, I do give liberal partial credit. So if it didn't run perfectly, don't panic. Jeff, could you elaborate on your question just a little bit? Oh, okay, I see. So ordered is for, let's see, ordered is for factors, and it's whether they're ordered or not. And order just does a sort. So ascending or descending sorts, numeric or alphabetical. But ordered is specific to factors. So you can create ordered factors, or you can just leave them unordered where the levels are in whatever whatever order you started them in, whatever they came in. That's not right. Say it again, Paul. Oh, I see. You're okay. I missed a couple things here. Let me see.
No, just ignore me.
Okay.
Basically, order will return a numerical vector with the numbers of the order.
Right.
Right. So if your data frame is 3, 2, 1 and you want it in ascending order, order will return a vector that's 1, 2. 3, 2. What? I'm confusing myself. Anyways.
Well, so we've already sorted them, so it's returning that the first is the highest, the second is the second highest, the third is third highest. But it would actually return the rank, if you will, of each observation as a vector. So this is what the order returns. So if you have the vector, I'll just show this here, order of the vector, I forget what you said, 3, 1, 2 or something like that. So we know that 3 is the third. Actually, let me do different numbers here. So 50, 20, 10. If I run the order function on this, it'll say that the first entry is the third smallest, the second entry is the second smallest, and the first entry is the first smallest. And then if I did decreasing equals true, it's going to tell me that the first entry is the biggest, and then the second entry, and then the third entry. So that's what order returns. So basically what we're doing in these rows where or in these lines where we say order is we're saying calculate the order they should be in and then return the rows in that order. Okay, and we are officially out of time. We are supposed to go till 7:25, so we're actually a minute over. Any other questions, feel free to put them in Ask Your Instructor. I will post the link to this video once I get it up onto YouTube. So if you want to go back and watch any of it, or if you were late or left early. If you left early, I guess you're not hearing me. But any other questions, do let me know. And I'll see you all in 2 weeks or at office hours next Tuesday.
Thanks, Mike.
You're welcome.